Hi folks, welcome to the 9.3 lecture video part 3. And in this video, we're going to take a look at examples 4 and 5 so we get a little bit of extra practice. So let's get started. All right, let's take a look at example number 4. So we have 2xy prime plus y equals 10x squared. So our first thing is we want to make sure that we are putting our differential equation into standard form, right? So I noticed that in all the equations, I don't have anything in front of the y prime, it's just a 1. So that means I'm going to have to get rid of this 2x. So to get rid of it, I'm going to go ahead and divide every single term by 2x, all right? So it's going to look something kind of like this. Y prime plus 1 over 2x y equals 10x squared over 2x. Okay, so when there is a non-1 coefficient in front of the y prime, you do have to divide every single term by that, all right? Now, you also want to make sure that you are simplifying as you go. What I mean is over here, I can simplify this into 5x. All right, so take the time to simplify. It will make your life easier. All right, so this is really 5x. And so what this means is we've got our f of x over here and our g of x over here. Okay, so after we have our equation in standard form, then we got to find our integrating factor. Okay, so how do we find our integrating factor? We have let's say I of x equals e to the integral of 1 over 2x dx, okay? So remember, you take your, wrong color. You take your f of x, and that's the one that you put in the exponent of e, and you integrate. This is going to give us e to the 1/2 ln x. And this will be a common trick that we see. We're going to take that 1/2, we're going to bump it up to the power. So we get e to the ln x to the 1/2, because that allows us to take the e and ln and cancel them out. And so our integrating factor is x to the 1/2. That, don't forget, is the same as saying the square root of x, okay? So we've got our equation in standard form. We found our integrating factor. Step 3, we get to multiply everything by this integrating factor. Okay, so I'm taking my integrating factor and I'm multiplying it by the standard form of my differential equation. In other words, I'm multiplying it by whatever I wrote in step 1. So I'm going to multiply this by y prime plus 1 over 2xy equals 5x. Okay? All right, let's do some algebra. X to the 1/2 y prime, so that's multiplying it here. I got to multiply over here and multiply over here. So then I get x to the 1/2 over 2xy equals x to the 1/2 times 5x, right? So I've multiplied, but again, let's use our exponent properties to clean some things up, see what we get. And we get x to the 1/2 y prime plus 1 over 2x to the 1/2 y, right? So remember, when I'm dividing terms, I can take the exponents and subtract them. So 1/2 minus 1 gets me a 1/2 on the bottom. And over here, when I'm adding them, I'm going to do 1/2 plus 1. So that's going to give me 5x to the 3/2. Okay? Now we can start to see that we've got a u and a du, and we've got a v and a dv, all right? That's going to allow us to rewrite this. And let me move this all the way back up to the top. We can rewrite this left-hand side as the derivative of x to the 1/2 times y. Okay, the x to the 1/2 is my u, my y is my v. And all of this equals what we have on the other side, which is 5x to the 3/2. Okay. Now our step 4 is we are going to integrate both sides. And remember, the integration is nice because it'll get rid of the dx on that left-hand side. Really, all we have to do is integrate the right-hand side. Okay. So an integral of the derivative of x to the 1/2 y is equal to the integral of 5x to the 3/2 dx. All right, these two cancel, so I get x to the 1/2 y equals 5 times x to the 3/2 plus 1 over 3/2 plus 1 plus c. Okay. Now let's take it piece by piece. We're going to add some things. We get x to the 1/2 y equals 5 times x to the 5/2 divided by 5/2 plus c. And when I'm dividing by 5/2, it is the same thing as multiplying by 2/5. So really, I get 5 times 2 over 5 x to the 5/2 plus c, which is nice because these 5's reduce. And so I get x to the 1/2 y equals 2x to the 5/2 plus c. All right, last step. We're going to go ahead and divide over this x to the 1/2 so that we can isolate our y. Right? At the end of the day, we want to have an explicit solution like y equals something. All right, so I get y equals 2x to the 5/2 over x to the 1/2 plus c over x to the 1/2. And let's clean this up. And we'll get 2x squared plus c over the square root of x. And this is our solution. Okay, so let me get this all on one page for you. And there's our example 4. You can see that we're solving the same 5 steps as we did in the previous example. All right, let's do one more example here. We're going to take a look at 5, but since we have them both on the same page, I want to point out that 5 has initial conditions, which means we need to find a value for c, okay? All right, let's go. Number 1, standard form. When I look at this particular equation, I get y prime plus 2x, y equals 4x, already in standard form. All right, this 2x is my f of x, and this 4x is my g of x. All right, let's find our integrating factor. Our integrating factor is e to the integral of my f of x. All right, this one might be one of the easier integrals that we've seen. Integral of 2x is just x squared, so we get e to the x squared. Now, because there's no ln in my exponent, that's as simple as I can get. Okay, so I don't bring the 2 down and then cancel some things out. That's only when there's an ln there. All right, let's multiply. Multiply everything by that integrating factor. So e to the x squared times y prime plus 2xy equals 4x. I'm going to distribute that e to the x squared to every single term in there. And I'm going to get e to the x squared y prime plus 2x e to the x squared y equals e to the x squared times 4x. Okay. All right, let's figure out what our u and our du and our v and our dv are. So e to the x squared is our u. And in order to find du, I would need to use chain rule. So that's where that 2x comes from, because it's e to the x squared times the derivative of x squared, which is 2x. That makes this our v and this our dv, which means we can rewrite the left-hand side as the derivative of e to the x squared times y. Okay. All right, so let's bring it back up here. Now we are going to go ahead and rewrite. So we've got our integral of our derivative of e to the x squared y is going to equal the integral of the other side. So integral of 4x e to the x squared dx. Okay. Integral and derivative, those cancel each other out. So we get e to the x squared y equals, all right, how are we going to integrate the other side? Well, doesn't look like a simple integral, so the first thing we should always try is u substitution, all right? So let's let u equal x squared, then du equals 2x dx. But since I have a 4x in here, let me take this and multiply both sides by 2. So that's going to give me 2 du equals 4x dx. Okay. I know we're usually used to like dividing things over, but you can also multiply up to get what you need as well. All right, this is going to give me integral of e to the u times 2 du on the right-hand side. So this will give me 2e to the u plus c. And if we plug back in our u, we got 2e to the x squared plus c. All right. Last step here, let's isolate our y. And we can do that with a quick division of our e to the x squared. And so we get y equals 2e to the x squared over e to the x squared plus c over e to the x squared. But we can be clever here and notice e to the x squared and e to the x squared are just going to reduce to 1. So really, I have y equals 1. Oh, no, sorry, 2. 2 plus c over e to the x squared. Now, if I was not given any initial conditions, I would be done, but we have the initial conditions 0 for x and 5 for y. So let's plug those in to find our c value. 5 equals 2 plus c over e to the 0. Okay, well, we know e to the 0 is 1. So really I have 5 equals 2 plus c, and that gives me c is 3. And so my last step, I'm going to go back to my equation, my solution, but I'm going to put in a 3 everywhere I see a c. So this gives me y equals 2 plus 3 over e to the x squared as my particular solution to this first order linear differential equation. Okay, so there it is all on one page for you. I'm going to come back and do a last video where we take a look at an application question, and then that'll be it for this section.